Welcome to our introductory presentation for IST 250. Let's begin. What are some of our goals for this course? Well, at the end of this course, you will be able to perform a written critical evaluation of any website using specific criteria for evaluation. You'll be able to develop a written and/or electronic comprehensive proposal for the design or redesign of a website. You will be able to collaborate in meaningful, deep discussions of the course topics with peers, experts, and faculty via interactive technologies. And you will be able to develop basic websites using HTML, JavaScript, and related technologies. As you can see, we have a full semester ahead of us, even though we're only doing it in 8 weeks. So let's delve a little bit deeper into the content. In this course, you will encounter a lot of terminology. What you see here on the screen is just a few of the terms that you'll encounter this semester. Things like web, web server, URL, internet, domain, client server, POP, IMAP. All of these terms will become more familiar as time goes on. Don't be overwhelmed by the sheer volume of words. So let's start with some basic terminology. What is a computer network? Many of you no doubt have computer networks even within your home, or perhaps where you work, or of course on campus. A computer network is just two or more computers connected together via hardware and software. The purpose of a network is to facilitate resource sharing, such as printers and an internet connection, as well as communication between devices within a network and between computers that are on separate networks, such as we have with the internet. Many of the devices shown here in this schematic may be things that you have in your home, such as a printer or router, or you may have heard of them, such as a switch or a server. So what is the internet? Well, the internet is a system of linked computer networks which share a common language, something called TCP/IP, which we'll delve into a bit more later. The computers on this network talk to one another using this TCP/IP language, and the internet, being the largest network in the world, connects computers across the world, even if they exist on very different or heterogeneous networks. We use the internet to allow those smaller networks to communicate across wide distances. When we consider how the internet works, we circle back to this idea of TCP/IP. This is the fundamental standard by which different devices on different networks can communicate. TCP stands for Transmission Control Protocol, and this is what allows two quote-unquote hosts to communicate and exchange data over what's called an IP network. TCP ensures reliability and provides error checking. It helps to do this by breaking messages into small packets which are then sent over the communication medium. IP, which stands for Internet Protocol, is responsible for routing those packets, or what we call datagrams, between the different nodes or computers on the internet. Its job is to perform that routing, and part of that is to find the best path between two different nodes. Something you may have heard of in your travels is the idea of an IP address. This is simply a numeric identifier which uniquely identifies a host computer or device. IP addresses are normally 32 bits in length. With IP version 6, they are 64 bits in length. Often you see them written as 4 decimal numbers separated by decimal points. The sections together comprise both the network ID and the host ID. You see an example here, 72.32.138.96. This is an example of an IP address. Now, these are normally assigned by a network administrator or via some automated protocol, such as DHCP, which is often in use at Penn State, or I should say on Penn State campuses, for their classroom lab environment. Basically, when you log in and your computer is being used, it's assigned a IP address which you can use until the computer is either logged off or shut down, upon which that number is returned to a pool for use by somebody else. So we've talked a little bit about what the internet is, but what's the World Wide Web? Well, this is something slightly different. The internet is a series of linked computers and computer networks. The World Wide Web is a linked set of web pages which are stored on some internet computers, otherwise known as web servers. It was created about 1989 by a gentleman named Tim Berners-Lee, whose picture appears on the screen, and it was made popular in the 1990s by companies like Mosaic, Netscape, and America Online. As the web has grown in popularity, there's been a drive to standardize many of the technologies that are available via the web. The World Wide Web Consortium, or the W3C, is the standardization group which makes recommendations and develops prototype technologies for use on the web. Some of the topics which they address include web architecture, web design, web accessibility, and even digital rights management. As a side note, the Obama administration turned over U.S. control of the Internet over to the international group ICANN in fall 2016. Prior to this, it had been managed by the United States. The concept of universal design is one in which we hear increasingly about. This quote here sums it up. Quote, "The design of products and environments to be usable by all people to the greatest extent possible without the need for adaptation or specialized design." Unquote. Normally when you hear the terms universal design, very often you hear it in relation to people with disabilities or to different platforms such as mobile versus PC, making content available to all. Accessibility is a key concept of web design these days. Accessible websites provide accommodations to those who may need it, such as individuals with disabilities. Much of this is codified into law, and any organization looking to improve their web presence and to attract the most people will definitely make their web presence accessible to all. Let's take a moment and talk about network configurations. Local area networks, or LANs, are small networks that you see often in places like the Penn State campus that you happen to be housed at, or even within smaller organizations. These are networks which connect computers, printers, storage, etc. in a small geographic area, such as a building, such as even a small campus. The primary function of these LANs are to share resources. Remember, we talked about computer networks. One of the primary functions there is to share resources. Often you see this manifested through a shared printer or a shared internet connection. LANs typically have high data transfer rates, but they often have high costs due to maintenance, upgrades, and the personnel who need to be dedicated to keeping them running. Contrasted with a LAN is a wide area network, or a WAN. These connect smaller networks spread over a large geographic area. WANs are sometimes called internetworks, which are collections of individual networks functioning as a whole. And the common functions with WANs include web browsing, email, remote access, and file transfer. For example, the Internet is a WAN. Routing can be used is used to determine how packets get from one node to another node within a WAN. Routing becomes especially important if you're going to communicate over large distances. Another term you're going to run across in your readings this week and beyond is the idea of client-server architecture. The reason you're going to hear a lot about this is it's the most common way of sharing processing power that's in use today. In general, one or more client computers send requests to a central computer, otherwise known as a server. The server then processes these requests and sends a response back to the client. Let's take a moment to consider protocols and names. Protocols are nothing more than rules of communication. Keep in mind that no one protocol does it all. The Internet is a diverse mix of protocols for specific functions. We've already mentioned TCP/IP as sort of a standardized language that is used to communicate between different computers on the Internet. But what about applications? For example, suppose we want to transfer files from one computer to another. One protocol that can enable that is FTP, or the File Transfer Protocol. HTTP, or Hypertext Transfer Protocol, is a protocol used to view web pages. No doubt when you've typed something into a web browser, you started it off with the letters HTTP. There are also a variety of email protocols available. Here are some of the standard ones. SMTP, or the Simple Mail Transfer Protocol, is used for sending messages. For receiving messages, you have a choice of POP, the Post Office Protocol, or IMAP, the Internet Mail Access Protocol. As I said, we mentioned TCP/IP, and we mentioned that it's a fairly standardized protocol for the Internet. Another Internet concept that we need to discuss is the idea of domain names and URLs. When we talk about a domain, we're talking about a set of Internet computers, usually for one organization. For example, Penn State has many computers, but one top-level domain, which is psu.edu. All computers on the Penn State network fall under that top-level domain. Now, two things which allow us to find things on a computer network are URIs and URL. A URI, or a Uniform Resource Identifier, does not necessarily specify a location or an access mechanism, but is simply a resource identifier. A URL, however, a Uniform Resource Locator, represents the location of a specific network resource, such as a page, an MP3 file, etc. And we see an example of one here using something that has been housed on my website. Notice that it specifies an access protocol, a web server, a folder, or folders actually, in this case, and a file name. This is a URL identifying a specific resource, in this case a file named meter.cpp, along with information about where it is and how to access it. You may have heard the term DNS in your travels as well, which stands for Domain Name System. This is something that links domain names with IP addresses, allowing requests to be routed to the proper location. For example, www.psu.edu has an IP address of 128.118.146.135. Either the URL www.psu.edu or the IP address can be used to access the website. However, for both, we need the HTTP portion to actually say how. The Internet is filled with languages, so let's take a look at a few. The most basic language that we're going to be learning about this semester is HTML, the Hypertext Markup Language. Now, it includes tags, which are used to help us format information for display on the screen. Ultimately, HTML pages are designed to tell the web browser how to display a document. Now for us, we're going to focus on HTML5. Prior to HTML5, HTML4 was the standard for many years, and it tended to be very flexible in terms of certain rules. However, as we're going to learn this semester, HTML5 is less flexible and has more strict rules. Another language you hear about this semester is XML. HTML is all about documents, describing how documents should be displayed on the screen. XML is not about presentation, it's about how to structure data. It's a text-based way in which data can be transmitted. It's also a text-based way in which data can be structured for use with HTML. Now, it's a very strict language. It requires well-formed quote-unquote documents with no structural errors. Now, you may also hear the term XHTML, which is the combining of HTML4 and the strict rules of XML, but we're more or less replacing that with HTML5 these days. This is the end of our presentation. You should go back and read Chapter 1 of your textbook, which includes many of these concepts.